Here we are working with a stats and probability problem. Given a series of potentially but not necessarily fair coin tosses with n trials and probability of heads p, return the probability that the number of heads is less than or equal to x. So this follows a statistical distribution called the binomial distribution. The binomial distribution applies when you are doing something with a binary outcome, like flipping a coin, repeatedly for many times, and each time there's a probability of success p. So if you're flipping a fair coin, then that value of p, probability of heads, is going to be 0.5 or 50%. And let's say you're flipping a coin 40 times. Then you're dealing with the binomial distribution with the value of n as 40 and the value of p as 0.5. Let's look at the Wikipedia definition of the binomial distribution, because that is going to be very helpful to us. We see that there's not just one binomial distribution. So in this picture, we're working with something called the probability mass function, or PMF. It defines, and you have different curves. You have a blue curve, a green curve, and a red curve. And these curves are based on different versions of the binomial distribution. You could have a bunch of basically infinitely many binomial distributions defined by any value of p and any value of n. You could have 50 coin flips trials, or 30 trials, or 20 trials, or 10 million trials. And the probability of success could be 50%, but it could be 90%, or it could be 50.0001%. So you have infinitely many binomial distributions. Let's work with the red distribution for now, which is a fair coin, 50% probability of success, and 40 trials. What the probability mass function tells us is that the probability, which is on the y-axis, of 20 trials is going to be somewhere between 0.1 and 0.15% chance of happening. Whereas the probability of getting exactly heads, 40 heads when you flip a coin 40 times, is pretty close to 0, as you can intuit. And yeah, so that's the probability mass function. Related to the probability mass function is a distribution function that applies for the unfair coin tosses problem on MLPro. So the cumulative distribution function tells us the probability that you're going to have exactly x successes or less than x successes. So for example, if we flip the red one, again, represents a fair coin, 50% probability of success, and 40 tosses. If we have 40 tosses and 50% probability of success, then the probability that we're going to get exactly 20 heads or less than 20 heads is, as you could imagine, right at 50%. Because, if you're flipping it 40 times, you could expect about 20 heads. Of course, if you're flipping it 40 times, the probability that you could expect less than or equal to 39 heads is really close to 100%, because that's basically the probability that you get 0 heads, or 1 heads, or 2 heads, or 20 heads, or 35 heads. And all of those, the probability that you get one of those outcomes is pretty close to 100. And that is our cumulative distribution function, which applies to our MLPro problem, where we're looking at the cumulative distribution function for the binomial distribution. And the function name kind of gives away the statistical method that applies here. Maybe we should take that away. But fortunately, you can use scikit-learn to basically not force you to memorize the formula, but instead to just enter in the parameters of the formula, the n, p, and x, and get a probability back. So let's look it up. Scikit-learn binomial distribution. SciPy.stats. So the SciPy.stats library, we will go ahead and import the binomial distribution. And now that we have the binomial distribution, we can call it CDF method with the given parameters, which are, again, the number of trials, the probability of success, and the number of trials we're measuring the probability of being less than or equal to. In the SciPy version, the parameters are shifted a bit. But yeah, if we run this code, which I'll have to sign in to do, then it should work out. So, okay, I'll go ahead and go here and run it on this other version where I am signed in, and yay, all the test cases passed. So that is the binomial distribution for you, and in particular the cumulative distribution of the binomial distribution. Cumulative distribution function. You can have cumulative distribution functions for all types of distribution. So like there's another distribution called the Bernoulli distribution, and that distribution also has a probability mass function and a cumulative distribution function. You have a bunch of different ones. You can have a normal distribution, that's the bell curve, and you also have a probability distribution function and a cumulative distribution function. So that's a little bit of stats for you. Many more to come in future MLPro problems, and definitely continue practicing our statistics questions to prepare for your data science interviews in particular. Thanks and have a great day.